For logarithm function, first of all, as you know, logarithm is the inverse of indices or exponential. So, before this, you have learned that in indices, you kena deal dengan horizontal asymptote. Jadi terbalik dia adalah vertical asymptote. So untuk logarithm function, you akan kena cari vertical asymptote. Okay, untuk sketching graph ya, first step, okay, is you cari nilai bila y0. For example, fx equal to log x base b. So log x base b equal to 0. You need to find the value of x. X equal to b power of 0. X equal to 1. So when x equal to 1, the value of y is 0. Okay, that is the first step. Okay, the second step is you find the vertical asymptote. The vertical asymptote is just you take the function here. So VA stand for vertical asymptote, yeah. So x is equal to 0. That is the vertical asymptote. When x, then you take the value of the vertical asymptote. You check when x approaching to that vertical asymptote, what is the value of y? For this case, log b0. This value will be too small. Too small sampai kita boleh anggap dia sebagai negative infinity. That's why they are approaching to negative infinity. Okay, and then the third step is when x approaching positive infinity. Contohnya log b 1 million. Alright, this one kalau you calculate dia akan jadi too big. So fx approaching positive infinity. Understand? Only 3 steps. Now we go to the sketching graph. First step, plot the point. Okay, and then the second step, plot the vertical asymptote here. And then in the second step also, as x approaching to 0 here, right? The value of y will be approaching to negative infinity ke bawah. That's why dia tarik ke bawah. Dia takkan sentuh x0. Understand? And then bila ke kanan ini x approaching positive infinity, the value of y akan approaching to positive infinity, naik ke atas. Do you understand? Alright, for the second case, when the value of b is between 0 to 1. Okay, now we go to the first step. Same, yeah. When y equals to 0, you find the value of x. For this case, is still the same. You akan dapat, contohnya log x asas b equal to 0. So, x equals to b power of 0, which is still 1. Okay, and then the second step, when x approaching 0. Okay, how do you get x approaching 0? Because you find the vertical asymptote first. So what is the vertical asymptote? You just take the function. So x equal to 0. So as x approaching that vertical asymptote, you check here the value of fx. Okay, for this case the special bila b, nilai b antara 0 sampai 1, bila you masukkan dia 0, dia akan, nilai fx dia akan makin membesar. Okay, that's why fx approaching to positive infinity. Understand? And then the third step, when x approaching infinity, the value of y will be approaching to negative infinity. Okay, contohnya you ambil log 0.5 1 million. You calculate yourself, dia akan jadi nilai dia terlalu kecil. Alright, so dia akan pergi ke negative infinity. Jadi kita boleh sketch graph. First step, when x equals to 1 here, point, yeah. And then the second step is the vertical asymptote, x equal to 0. Okay, and then when x approaching to 0, fx ke kiri, ya, naik ke atas. Okay, and then when x approaching to infinity, dia ke bawah macam ini. Okay, do you understand, everyone? Now we go to the sketching graph. First, tengok first step tadi, when y equal to 0, so ln 2x minus 1 equal to 0, e power of 0 equals to 2x minus 1. Rearranging the function, dia akan dapat x equal to 1. E0 is 1, ya, don't forget. The second step, find the vertical asymptote. So the function is only 2x minus 1. So the vertical asymptote is x equal to half VA. VA is vertical asymptote, ya. Then when x approaching to half, okay, ln 2 half minus 1, dia akan dapat apa? Ln 0. Betul tak? Right? Bila ln 0, you try tengok this value, dia akan jadi terlalu kecil. So fx dia will be approaching to negative infinity. And then the last step is when x approaching positive infinity, the value of fx will be approaching positive infinity, terlalu besar. Okay, cuba you masukkan macam ini. Yes. Okay, now lengkap 3 step. Now we go to the graph. Right. First is the point x equal to 1 around here, 1. And the vertical asymptote is x equals to half, since the asymptote, ya. Nah, dia garis putus. Okay. Now bila x approaching to half, y dia negative infinity. And then bila x approaching to positive infinity, y dia akan naik ke positive infinity, the third step. Understand? So last kali dia tak minta domain and range, tapi kita belajar je. Okay, so for ln atau logarithm, the domain is by referring to the vertical asymptote. Tengok kiri atau kanan vertical asymptote tu. Sekarang ni untuk this case, ada graf tak belah kanan kiri? Tiada. Jadi dia belah kanan. Jadi dia punya vertical asymptote dia half to positive infinity. Okay. Then range dia is from negative infinity to positive infinity. Faham? Y equals to negative ln 2x minus 1. The first step, when y equal to 0. So 0 equals to negative ln 2x minus 1. Ln 2x minus 1 equal to 0. Then e power of 0 equals to 2x minus 1. Then 2x equals to 2x equals to 1. Okay. The second step, finding the vertical asymptote to x minus 1 equal to 0. Okay. So x equals to 1 over 2. Alright. That is the vertical asymptote. Alright. Since ini dia tak boleh negatif ya, dalam ini tak boleh negatif, so dia greater than here. Ini pun greater than. Itu penerangan kenapa dia ke kanan. Alright. Then when x approaching to 1 over 2, okay, fx akan approaching to positive infinity. Okay, the third step, when x approaching to positive infinity, right? Fx will be approaching to negative infinity. Understand? Okay, now we go to the sketching graph. Alright. First step, 1 here, and then 1 over 2. The asymptote. Okay, now as x approaching to half, fx to positive infinity, it's like this, and then as x approaching infinity, like this. Understand? So what is the domain? Open half to infinity. What is the range? Negative infinity to positive infinity. Do you understand? Okay, y equals to ln 1 minus 2x. The first step is when y equal to 0, so ln 1 minus 2x equal to 0. Find the value of x. E0, 1 minus 2x. And you get 1 minus 2x 2x is equal to 0, x equals to 0. Right, and then for the second step, finding the vertical asymptote, 1 minus 2x must always be greater than 0. Sebab dalam ni tak boleh negatif. So you rearranging, dapat macam ini. And then you belajar chapter 2 dulu, jadi macam ini. Okay, then the vertical asymptote is x less than half. Bila x less than half, you kena ambil when x approaching to half. When x approaching to half, okay, the value here will be, the value of fx here will be approaching to negative infinity. You can calculate yourself. Okay, now the last step, third step, when x approaching to negative infinity. Okay, sebab dia lebih kecil tadi di sini. Right? Fx will be approaching to positive infinity. Jadi kita sketch the graph. Okay, x equals to 0 here, x equals to 1 over 2. Okay, so when x approaching to half, fx to negative infinity. When x approaching to negative infinity, fx to positive infinity. It's like that. Okay, now the domain. Okay, the domain, you look, now the graph is on the left of half. So dia daripada negative infinity, so dia akan jadi daripada negative infinity sampai half. Understand? And then the range will be negative infinity sampai infinity. Okay, that's all.
Fx equal to 2 plus ln x plus 1. Sketch the graph of fx and f inverse on the same x. And state the domain and range of fx and f inverse. For this question, we should not find its inverse. That only reflect the fx to get the f inverse. To sketch the graph ln fx equal to 2 plus ln x plus 1 by using the basic properties. Step 1. When fx equal to 0, 2 plus ln x plus 1 equal to 0, ln x plus 1 equal to negative 2, x plus 1 equal to exponent negative 2, and x equal to exponent negative 2 minus 1. By using calculator, the value is negative 0.9. Next, for the second step, find the vertical asymptote. For this function, ln x plus 1, that means x plus 1 must be greater than 0. X plus 1 equal to 0, x equal to negative 1. That means x must be greater than negative 1 for this function. When x approaches to negative 1, the graph approaches to vertical asymptote. Fx approaches to 2 plus ln 0.000001. That means 2 plus negative infinity. 2 approaches to negative infinity. Therefore, when x approaches to negative 1, fx approaches to negative infinity. And the third step, when x approaches to infinity, fx approaches to 2 plus ln infinity. 2 plus infinity. Therefore, when x approaches to infinity, fx approaches to positive infinity. To sketch the graph fx and the f inverse, first draw the dotted line y equal to x. And the second, draw the straight line and call vertical asymptote when x equal to negative 1. X equal to negative 1. Now, when y equal to 0, x equal to negative 0.9. And when x approaches to negative 1, y approaches to negative infinity. And when x approaches to infinity, fx approaches to positive infinity. And label the graph is fx. We can sketch graph f inverse reflect from the graph fx. When fx have vertical asymptote, the inverse is horizontal asymptote at y equal to negative 1. When intercept x exists at negative 0.9, the inverse is intercept y exists at negative 0.9. And the graph is approaches to horizontal asymptote at negative 1. And when x approaches to infinity, fx approaches to positive infinity. And here is the graph f inverse. Now, state the domain and range of fx and f inverse. Domain of the function is equal to the range of the f inverse. We refer the value of x greater than negative 1. So, from negative 1 to infinity. And the range of the function is equal to the domain of f inverse. From negative infinity to infinity. For example 5.32, given fx equal to 2 to the power 2x plus 3. That is called the exponential function. The question is, sketch the graph of f and f inverse on the same x and determine the domain and range of fx and f inverse. To sketch the graph exponential by using basic properties. First, fx must be greater than 3. Refer the function. And for x element of a real number. That means the horizontal asymptote for this graph is y equal to 3. And find the intercept y-axis. When x equal to 0, fx or f0 equal to 2 power 0 plus 3. 2 power 0 is 1, 1 plus 3 equal to 4. And third, When x approaches to infinity, fx, the function is to be greater and greater. Fx approaches to infinity. For the fourth step, when x approaches to negative infinity, that means fx is approaches to 2 power negative infinity plus 3. 2 power negative infinity is approaches to 0. 0 plus 3. Next, we try to sketch the graph exponential. First, number 1, the graph have horizontal asymptote y equal to 3. Y equal to 3 and the graph is intercept y-axis at 4. And when x approaches to infinity, fx is approaches to infinity. To the right and increase. When x approaches to negative infinity, to the left, fx is approaches to horizontal asymptote at 3. Approaches to 3 and label fx. Now we can try to sketch the f inverse. Sketch the vertical asymptote x equal to 3 and intercept x-axis at 4. And the graph inverse is approaches vertical asymptote at 3. And reflect the graph f inverse. And label f inverse x. For question B, determine the domain and range of fx and f inverse. The domain of the function is equal to the range of f inverse. The domain of the function is negative infinity to infinity for exponential function, and the range of the function is equal to the domain of f inverse. Refer number 1, fx must be greater than 3. Therefore, range of the function is from 3 to infinity, not including the 3. For example 5.33, the functions f and g are given by fx equal to 3 plus exponent 3x and gx equal to ln x minus 3 to the power of 1 over 3. The function fx is exponential function and the function of g is logarithmic function. The question is, show that f and g are inverse each other. Hence, sketch the graph of f and g on the same x. How to show that f and g are inverse of each other? We can use the concept f composite f inverse equal to x. For this question, find the f composite gx and to show that equal to x. Refer from the function f 3 plus exponent 3 and the input is gx, and 3 plus exponent 3 and the function gx is ln x minus 3 to the power of 1 over 3 equal to 3 plus exponent using the power rule, exponent ln x minus 3. And the concept exponent ln x equal to x. Therefore, 3 plus x minus 3 equal to 3 minus 3 plus x equal to x. Next, the concept is G composite G inverse equal to x. Now, find the G composite fx to show that f is inverse for G. Refer from the function G ln and the input is fx. Minus 3 to the power of 1 over 3. Ln the function of fx is 3 plus exponent 3x minus 3 to the power of 1 over 3. By using the power rule, 1 over 3 ln 3 minus 3 is 0. Therefore, ln exponent 3x. And the second time, by using the power rule, 1 over 3 times 3x ln exponent. 1 over 3 times 3x is x. And ln exponent is 1 equal to x. Now, shown f and g are inverse of each other. For the next question, hence, sketch the graph f and g on the same x. Hence, that means f and g are inverse of each other. We can sketch the graph f and reflect to find the graph g. By using basic properties, to sketch the graph exponential, first, fx must be greater than 3 for x element of real number. Why fx must be greater than 3? Because fx equal to 3 plus exponent 3x. When x approaches to negative infinity, the value of exponent 3x is nearest to the 0. And that means fx approaches to 3. And the second, find the intercept y-axis. When x equal to 0, f0 equal to 3 plus exponent 0. 3 plus exponent 0 is 1 equal to 4. And the third, when x approaches to infinity, to the right, fx approaches to 3 plus exponent infinity. Exponent infinity is the largest value. So, fx approaches to infinity. And the fourth, when x approaches to negative infinity, fx approaches to 3. Now, we can sketch the graph exponent. To sketch the graph exponential, first sketch the horizontal asymptote. Y equal to 3. And the graph intercept y-axis at 4. By using basic properties, when x approaches to infinity, to the right, fx approaches to infinity, increasing. And When x approaches to negative infinity, to the left, fx is approaches to 3. Approaches to horizontal asymptote, but not touch the horizontal asymptote. Next, how to sketch the graph G? We reflect at y equal to x. When fx has horizontal asymptote, gx have vertical asymptote. X equal to 3. And intercept x-axis at 4. When fx approaches to horizontal asymptote, gx is approaches to vertical asymptote. Not touch the vertical asymptote, and we can reflect the graph G and the smooth graph gx. Okay, done.